In this video, I'll be going over our notes for linear functions. So we're in the second part of our functions unit, and this is our first set of notes. So we're going to be looking at the definition of a linear function today. A linear function is a function that will create a line when graphed on the coordinate plane. So think about the name linear, right? It's spelled L-I-N-E-A-R. It has that word line hidden right up front. So when you graph a linear function, it's going to show up as a line on the coordinate plane. So on each of these pictures below, we have four graphs. There's four set of axes and then graphs on top of them. So we can see that this first one has the graph of a line. This is a linear function. In the second one, we have a function because this passes the vertical line test, but it is not just a straight line. This is something called a parabolic function that you'll learn about later. Then we have a linear function here. So it's making that straight line. This one has more of a curve, and it might be a cubic function, again, something that you'll learn later, so not a linear function. So when we're going to be looking at our specific functions during this unit, we're going to have straight lines only. Once we have linear functions, there's two types of relationships that they can be. They can either be proportional or additive. So a proportional relationship will always go through the origin, while an additive relationship will never go through the origin. So we've got two different graphs here. On the left side, for our proportional relationship example, it's all about water use. It says that throughout the 0 to 10 minutes that are graphed on this specific coordinate plane, we have the water used measured in gallons. So we can see that it is starting at time 0 at 0 gallons. So it's been 0 minutes and you've used 0 gallons. Then at 10 minutes, and this should say minutes, not seconds, at 10 minutes, there have been blank number of gallons used. So we need to look on our axis that is labeled as minutes, find the 10, and then go up to our line and see how many gallons it's been. So when I look horizontally across here, it's all the way at 50. So it takes 10 minutes to use 50 gallons. So you could find out how much does it take to go maybe 6 minutes. Well, that would have been 30 gallons. If I have 2 minutes, it's taken 10 gallons up. So how much would it take, or how long would it take to have for 1 minute, how many gallons would we get? So we look at our 1 on our time for our minutes, and we line up to this marking right here. It's halfway between 0 and 10, so that would mean that in 1 minute, you use 5 gallons. So the unit rate for this would be 1 minute for every 5 gallons, or 5 gallons per minute. In our next example of our additive relationship, we notice that it does not go through the origin. So that means that at the number of tickets being 0, so you haven't bought any tickets, to just enter this theme park, you're already paying this amount because at number of tickets is 0, we are already above 0. So the cost is somewhere between 16 and 24 on this y-axis. So somewhere between there is going to be 20 because it's right on that line. So we're counting up in intervals of 4 here. So it costs $20 to go to the theme park and buy 0 tickets. So that means that the entrance fee here was just $20. So just to get in, you have to pay that. Then if you want to purchase tickets on top of that, your price is going to continually increase. So to go to the theme park and buy 6 tickets, that means we would be looking down here for our number of tickets, following the line up, and we end up at this point. When I check and see where that goes to, it's at $32. So it costs a total of $32 to go to the theme park and then buy 6 tickets on top of that. So if my entrance fee is $20, my total that I'm spending for 6 tickets is $32. That means that just on the tickets alone, I spent a difference of $12, and I got 6 tickets. So if I were to just buy 1 ticket, that means that I could find the price by taking the $12 divided by the 6 tickets that I purchased, and that means that every ticket equals $2. So if I were to go buy 1 ticket, that would come all the way up here, and see how that's partway between 20 and 24 on our y-axis. So that would be 22, or the $20 entrance fee plus the $2 tickets. And that's going to continually increase the more tickets you buy the more your total cost will be. So when we want to write the equation for any of our linear functions, we're going to use the linear equation called y equals mx plus b, or slope-intercept form. So that's the formal name of it, and this equation down below is our representation of it. So we're used to seeing y and x in our formulas, but normally we see numbers here. So those numbers that we're used to seeing actually have names that we haven't really been using yet. So our m value, the number that's the coefficient on x that multiplies it, is what we call our slope. The b value that we either add or subtract from that x value is going to be called the y-intercept. And we'll talk a little bit more about what those mean on the graph in a couple minutes. But we want to work on identifying them from the equation. Can we figure out what the slope will be and what the y-intercept will be? So in order to do that, we have to figure out, well, what letter is in the m spot and what letter is in the b spot. So when I look down at this example, it says y equals 2x plus 3. The number that is the coefficient on x, the one that's multiplying the x, is 2. So that's going to be my slope, or my m value. So the slope there is 2. The y-intercept is the number or the constant that is either being added or subtracted onto that x value. So we can see that we're adding 3. That means the y-intercept would be positive 3. If you think you get the hang of it, go ahead and try the next few. Pause the video and press play to check your work. We have the next one, identifying the slope. Negative 4 is the coefficient that's hanging out with x, and positive 7 is the constant that is being added to x. So our slope here will be negative 4, and the y-intercept is positive 7. In the last example, the coefficient that is in front of the x, multiplying it, is our slope, and that value is 1/2, and you can either write it as a fraction or as a decimal, it's up to you, so 0.5 or 1/2. And then our y-intercept, again, is that constant that is either being added or subtracted from the x. This time we see it says -4, so that means the y-intercept will be negative 4. So we have to use that sign that was in between to make a decision on whether we have a positive y-intercept or a negative. The first two were pluses, so we had positive y-intercepts. This last one has a minus in the equation, so it will have a negative y-intercept. So let's look at exactly what does slope and y-intercept mean. So the slope is our m value, like we said. It's the number that multiplies x in the equation, but it means how steep a line is. And we can define it mathematically by finding the rise over the run. So we'll say that phrase a lot, rise over run. So when we talk about how steep it is, we're looking at, is it something that is going positive, negative, 0, or undefined? So when I talk about a line from left to right that's going upwards, if I were to draw a little stick figure on this line and look at it from left to right, this little guy's going up a hill, so he would have a positive slope. But then maybe this stick figure is on this line, and again, looking from left to right, this stick figure is going down, so this would be a negative slope. If I drew a stick figure on this line, this guy is walking from left to right on flat ground. So that's pretty easy. It takes 0 effort to walk on the ground if it's flat, right? We don't have to put much effort into that. So if we call it 0 effort, it's going to help us remember that a line that is completely horizontal will have a 0 slope. Then the last type of line here is when we have a vertical line. And when we see this on our graph, if we were to look at it from left to right, well, it's kind of hard to do that because the person would be walking up the wall. And we can't do that. That's impossible. So that will be one of our undefined slopes. So those are the 4 types of slopes that we can have. Now within the positive and the negative, in order to find the value, we're going to use that formula of rise over run. So to find those on the graph, we're going to choose 2 points. So just like we've been doing in our functions unit, you just pick any 2 points that are on our line. Now these 2 points that I just picked are good points because they're right at the intersection of the coordinate plane lines that are already there for our graph. But if I just picked this point, it's kind of in between boxes, so it's hard to see exactly what integer it is. So that would not be a good point to pick. If I pick a point that's out here, That's not even on my line, so I can't choose that either. You have to choose 2 points that are on your line, and it does not matter which 2 you choose, it just has to be any 2 points on the line. From those 2 points, you're going to calculate the rise, so how much are you moving up and down, and the run, so how much are you moving horizontally. So to go from one point to the other, I had to move 3 boxes up. I went 1, 2, 3, so I went plus 3 for my rise. And then from there, I went over 1, 2, 3 boxes to the right. So because I moved to the right, that's again positive 3. So for rise over run, I would put my rise of 3 over my run of 3. And we can simplify that. 3/3 is equal to 1. So that means my slope in this graph would be 1. So let's find the slope in the second equation. Start by picking 2 points. It can be any 2 points, so I'm going to choose these 2. Do your rise and your run and count the boxes. So the rise is up 2. That means we're going to the right 2, positive 2. Then we went to the right 1, and since we went right, we're going positive 1. So the rise was 2 over a run of 1, and 2 divided by 1 gets us 2. So our slope in the second line is positive 2. In our last line, we have a different looking line. Notice the first 2 looked like this little guy going up the hill if we went from left to right. But now we see that our line is going downwards from left to right. So this is going to have a negative slope when we're done calculating it. So we want to pick 2 points just like we did before. I see that these are 2 nice points right on the corners there. I'm going to figure out, well, what's my rise? And remember, rise means vertical movement. So sometimes it might go down. Like in this case, we have to move downward to find our next point. So I'm going down 4, which means I'm subtracting 4 or minus 4. And my run is my horizontal movement. That's plus 3 because I am going to the right 3. So this time my rise is negative 4 when my run was positive 3. So a negative divided by a positive is just a negative. So our final slope will be negative 4 over 3. And you're going to leave it in a fraction like that when you talk about your slope if it can't be simplified. So now that we've looked at our slope, the other part of our y equals mx plus b formula was our b value that we defined as our y-intercept. It's where the line will cross the y-axis. So we want to look at our graph at the y-axis specifically and see what number it is crossing. So this one's a little bit hard to see, but these numbers were labeled there, meaning these are our 2 axes. Where the 2 axes meet is your origin, or 0, 0. And it looks like our linear function here was going right through the origin. So that means that where it's touching the y-axis, so that where it intersects with this line, the value of that is 0. On our next one, this was our y-axis, this was our x-axis, so the origin was here. We want to look and see where did our line, so the linear function that was given, intersect with the y-axis. And we can see that that point is right here. So this box was 1, this box was 2. That means that our line is intersecting the y-axis at the point 3. In the last graph, we look at our axes, so we can see these a little clearer here. The x and the y-axis are below. They're intersecting at the origin. We can see that our linear function is right here. So we want to know, where is it touching the y-axis? So I can see that it is crossing 1, 2, 3, 4, 5 spaces above the origin, so my y-intercept will be positive 5. So now that we've gotten our slope and our y-intercept for each graph, we can write their equation by filling in the form y equals mx plus b with the values we just got. Remember, our plus b is the y-intercept, so all of these values that we just found. And our slope value is the m. So that is the one that we found first with rise over run. So our y needs to stay every time. We'll always start with our y. The slope in the first one was 1. X will come down plus our y-intercept of 0. So the equation is y equals 1x plus 0. That was plugging in our 1 for our slope and our plus 0 for our y-intercept. we can write this a little bit neater, because if we add 0 to something, it's just going to be itself, so that would just be the same as 1x. But we also know that when we just have 1x, we could write it as just plain old x, because when we see an x, we know there's a hidden coefficient of 1 that's multiplying it. So that means that the final equation would be y equals x. If you left it in this form, it wouldn't be wrong. We can just simplify it a little bit more by saying it's y equals x. In the next one, we have slope of 2 with a y-intercept of 3. So we're going to plug that into y equals mx plus b. So my m value this time was 2 for my slope. That's the coefficient with x. And then my y-intercept was positive 3, so I'm going to write plus 3. Then in my last one, my slope was negative 4/3, so I'm going to write y equals, and then plug in my slope value, so negative 4/3. It needs an x next to it because the slope is always the coefficient on x. And then we add or subtract our y-intercept. In our y-intercept, we had positive 5, so we'll write plus 5. On these last two, you're going to be given the slope and the y-intercept, and you are going to need to put the graph on here. So your line is not given this time, we're just given the information of the slope and y-intercept. So in our first example, it says graph a line with a y-intercept of negative 3 and a slope of 2. So that means that my b value is negative 3, and my slope, or m value, is 2. So in order to plot the y-intercept, we're going to find the y-axis and go to the value that was given. So the y-axis, the y-intercept, is negative 3. So that's 1, 2, 3 spaces below the origin on the y-axis. So that's one point that I already know will be on my line. Because it has a slope of 2, that means that the rise over run is equal to 2. Well, when you see rise over run, you see it's in a fraction. So to write 2 in a fraction, we know it's really over 1. So that means my rise will be 2 when my run is 1. So from the point that was already on the graph at negative 3 on the y-axis, we're going to count 2 boxes up and 1 box to the right. So I rise 2 plus 2, and then I ran 1, so plus 1 to the right. And then I'm going to keep doing that until I create a line that I can make by connecting my dots. So I'm going to rise 2, run 1. So notice I went up 2 boxes and then to the right 1. I'm going to keep doing that until I have my line. So up 2, over 1. So now I can see that if I connect these points, I'm starting to see a line. But I can also go backwards. I could go down 2 and to the left 1. Down 2 and to the left 1. Because if I do a rise of negative 2 and a run of negative 1, then a negative divided by a negative gets me back to my positive slope of 2. And that's how we can finish graphing our slope onto our x and y axis. So finally, to plug this into our equation, we want to find the y equals mx plus b form. We already identified m as being 2, so in the m spot we write a 2, x plus our b value. Well, this time we have a negative 3, so it's really plus negative 3. But if you're adding a negative, remember that's the same as just subtracting a positive. So we'll have our 2x minus 3, and we can rewrite it like this. Either way would be accepted, but you'll typically see it as a minus sign when it's that negative y-intercept. And finally, in our last example, we are asked to graph the line y equals negative 1/2 x plus 5. We have our number in front of x, which is our slope, or our m value, and that's given to us as negative 1/2. Then we have our y-intercept as plus 5. That's our b value in the equation, and it's a positive 5. So when you're going to put this on the graph, always start by plotting your y-intercept first. So go onto your y-axis and find positive 5. That'll be the first point on your graph. And then your slope is negative 1/2. So that means we're going down 1 and to the right 2, because a negative divided by a positive will be our negative slope. Or you could also do positive 1 divided by negative 2. As long as you are doing one positive and one negative, it doesn't matter. So I'm going to go down 1 and then to the right 2. And that gets me this point. I'm going to keep going, down 1 and to the right 2, down 1 to the right 2. And then from my original point, I'm going to try the opposite. I'm going to go up 1 and to the left 2. And that gets me another point that's in line. Then I'm going to go up 1 and to the left 2. And now I've plotted as many points as I can fit on this graph that will be on my line. I'm going to carefully connect them and draw the arrow on either end to show that it's going on forever. And there is my graph of this equation, y equals -1/2 x plus 5.